In this section, I'm going to summarize some of the main topics or concepts that you find under the topic on momentum, which is mechanics. So I've listed the concepts here. The first one is we are going to define momentum. What is momentum? And then we'll also cover the change in momentum, which is delta P is equal to P final minus P initial. We'll also cover Newton's second law in terms of momentum. Number 4, we've got the definition of impulse. It's another concept as well. We've got the principle of conservation of momentum. And then we have got elastic and inelastic collisions. So these 6 concepts are very key to understand in this topic. So let's get into momentum. What is momentum? Momentum is described as the product of the mass and velocity of a moving object. So basically, momentum is a measure of any object's amount of motion. According to the Newtonian mechanics, momentum is used to measure how easy or difficult it is to stop a moving object. So Newton, what he's saying here is that there are 2 things that determine the extent to which we can stop a moving object, or whether it is easy to stop that moving object. And these quantities are 1, the mass of an object, and the velocity of an object. Meaning that when the mass of an object increases, it is not easy to stop that moving object, as well as the velocity of an object increases. When the velocity of an object increases, it's not easy to stop that moving object. So momentum is symbolized by the letter P. We use P, and P is defined as, the formula that we use, P is equal to m times v, meaning that momentum is equal to the product of the mass of an object and the velocity of an object. You will find that when the mass increases, when the mass of an object increases, momentum will also increase, as well as when the velocity increases, the momentum will also increase. So these 2 quantities, they determine how easy or difficult it is to stop a moving object. So the product of these 2, to some extent, give us an amount of motion of an object. So it is a measure of the amount of the motion of an object. One thing we also need to remember here is that momentum is a vector, and the vector is determined by the direction of the velocity. Remember, velocity is a vector. A vector is a quantity that is with magnitude and direction. So when we specify momentum, we also need to specify the magnitude and the direction. So the velocity will determine the vector or the direction of the momentum. The units that we use for momentum, we use the kilogram meter per second. Kilogram meter per second. You'll find here that we are multiplying the mass in kilograms and the velocity in meters per second. So our unit is in kilogram meter per second. Then secondly, when the velocity of an object changes, the momentum will also change. So here we are talking about the change in momentum. So when the velocity of an object changes, the momentum will also change. So we can calculate change in momentum as delta P, which is equal to the final momentum is P final minus the initial momentum, P initial. So when we put in the formula, our final momentum, we define it as mv final minus mv initial, where we are talking about the mass, because in most cases we are looking at the same object, so the mass will not change, but the velocity is the one that changes. So when the velocity changes, the momentum will also change. We can factor out m to give our formula as mv final minus v initial. So that formula will give us the change in momentum. For example, when we have a trolley of mass 2 kg and velocity, let's say 3 meters per second, traveling to the east, and the same trolley now increases its velocity, same mass 2 kg, but it is now moving at a velocity of 4 meters per second. So we can calculate the change in momentum as the mass, which is 2 kg, the final velocity is 4 meters per second minus the initial velocity, 3 meters per second, and then this will give us 2 kilogram meter per second as the change in momentum. So the difference in the velocities multiplied by the mass of the object. One more thing also that we need to take note in momentum is what is referred to as the Newton's second law in terms of momentum. In your exams, you may be expected also to state this principle here to express Newton's second law in terms of momentum. In words, we state it as follows. The net force acting on an object, let's put it here, the net force acting on an object So we express in words Newton's second law in terms of momentum as follows. The net force acting on an object is equal to the rate of change of momentum. Now, this statement is derived from the fact that when we take Newton's second law of motion is given as F net is equal to ma. Okay, the net force acting on an object is equal to the mass of the object times the acceleration. What we know is acceleration is given as the change in velocity over the change in time, which we can write as v final minus v initial over delta t. So in this case, we can substitute the acceleration here with this statement, because this statement is representing acceleration, such that we can write our F net as the mass multiplied by our acceleration, but our acceleration is v final minus v initial over delta t. So when we combine this statement here, which is mv final minus v initial over delta t, we'll find that this statement we have on top here, which is mv final minus v initial, is the same as the change in momentum. So we can replace that statement with delta p over delta t. So much so that we will have a statement, our Newton's second law will now have been converted to F net is equal to delta P over delta T. And in words, we state this as the net force acting on an object is equal to the rate of change of momentum of the object. So we can write the net force as delta P over delta T, which is the change in momentum over change in time. Now, there are cases where we have to use this formula in our calculations, so it's also one of the most important formula that we get. This formula, it leads us also to another concept that we need to cover here, which is impulse. Now, impulse is defined as the product of the net force acting on an object and the time the net force acts on an object. So from this statement, we are basically saying in symbols that impulse is equal to the net force acting on an object multiplied by the time that net force acts on an object. Okay, so impulse is the product. It means we are multiplying the net force acting on an object, and we are also multiplying by the time that net force acts on an object. Now, this may not look like a new formula, because when I take the Newton's second law of motion in terms of momentum, when I write it down here, we have got F net is equal to delta P over delta T. Now I'm going to manipulate this formula so that I multiply by delta T, multiply by delta T. So you'll find that this formula can transform into F net times delta T, which will be equal to delta P. So basically what we have here, this product of the net force is what we are referring to as the impulse. It's what we are referring to as impulse. So from this statement, we can also see that impulse, we can write it as being equal to 1. We can say impulse is equal to F net times delta T, or F net delta T, but also the same F net delta T from Newton's second law of momentum, second law in terms of momentum, it is giving us delta P. So we can calculate the same impulse as change in momentum. So there are two ways that we can calculate impulse. Number one, using the formula F net delta T. Okay, so the implication here is our units are Newton seconds, because we are multiplying Newton and time is in seconds. Or when we use this formula, our units are also in kilogram meter per second. So take note that we have got two definitions for impulse, which are the net force multiplied by the time acting on an object, and also we can calculate it as the change in momentum. Now, the significance of impulse is basically to the effect that when you apply a force on an object, let's take, for example, you have a trolley here that you want to push, okay, or an object, or we can take, let's say, a car that you want to push, right? For you to set the car in motion, for you to set this car in motion, there is a force that you need to apply on this object. Okay, but you'll find that for you to get to move the car in motion, that force that you apply there, you have to push the car for at least a certain length of time. You cannot just place your hands and remove your hands and expect the object to move. So your force, the force that you apply here, you have to act, it has to act on the car for a length of time, for a length of time. And then when you keep on pushing, you'll find that the car, you get it to moving. So that impulse, the product of the force and the length of time that you are applying or pushing on the car, is what we call impulse. So you'll find that the greater the force, or the greater the time, the greater the impulse of an object. So that's what we have under impulse. Then also one more concept that we cover is what is called the principle of conservation of momentum. The principle of conservation of momentum is one of the concepts that constitute a greater portion of the marks in the exam here. So one, you also need to state the principle of conservation of momentum, okay, in words, and then do the application. So in words, the principle of conservation of momentum is stated as follows. In an isolated system, the total linear momentum is conserved. Okay, as simple as that. In an isolated system, the total linear momentum is conserved. Some texts put it as follows. When objects collide, the total linear momentum before collision is equal to the total linear momentum after collision, provided there are no external forces acting on the objects. So let's dissect this principle for a while, so that it's very important that we understand this principle. Now what I have here are a system of, let's call them trolleys. Okay, so this trolley has got a mass, let's call it mass 1, and this one has got a mass 2. Okay, and this one is moving with a velocity. Let's take, we call that velocity 1. It's moving to the right, and this one has got also a velocity. Okay, let's take it moving to the left, which is velocity 2. Okay, now assuming that these two trolleys are moving in a straight line, So straight line, that is a linear momentum. So what the principle of conservation of momentum is stating here that as they are moving towards each other in a straight line, that is the linear momentum, we can add up their momentum. Remember, momentum, we said that is the product of the mass of the object and the velocity of the object. So this object 1, it has got its momentum, which is a P initial, okay, we can call it P1, okay, and this one is also, it has got its momentum, which is P2, okay, and we are going to add the two momentum, that is the total linear momentum. So this principle is saying that when these objects, should they collide, let's say they are going to collide, they are moving towards each other, they are in a straight line. When they collide, so this is a before collision. When they collide, let's assume that over here they do collide, okay? So this trolley M1 will move in the opposite direction. Let's say that will be V1, and the trolley 2 M2 will move in the other direction, which is V2. Okay, now the velocity after the collision, we'll call it the final velocity. So this is a V1 final and V2 final. The velocities before collision is going to be initial and initial. So we can calculate the total momentum before they collide and the total momentum after collision. So what we are basically saying that the total momentum before they collide, it will be equal to the total momentum after collision. So that's what we are saying in this statement. When objects collide, the total linear momentum before collision is equal to the total linear momentum after collision, provided there are no external forces acting on the system. That is an isolated system. So we can put this in a formula as M1 V1 initial, which means the initial momentum of trolley 1 plus the initial momentum of trolley 2, that is our total momentum. It is conserved. Conserved means it doesn't change, or you can put it here as remains constant. You can also put it as remains constant, or it remains the same, or it does not change. So the total momentum before collision, it will be equal to the total momentum after collision, which is M1 V1 final plus M2 V2 final. So that formula will give us the formula for the principle of conservation of momentum. Okay. You will find that most of the time we summarize this as the sum of the initial momentum will be equal to the sum of the final momentum, meaning that the total linear momentum before collision is equal to the total linear momentum after collision. That is a very important equation that we are going to use and apply in our calculations. So we call this equation the principle of conservation of momentum. Now let's come to the other concept, the final concept that we need to cover here, summarize, is what is called the elastic and inelastic collision. Elastic and inelastic collisions. In your exam as well, you will be expected to define an elastic collision and of course an inelastic collision, as well as also calculate problems or questions based on elastic and inelastic collision. So we'll start by defining the elastic collision. An elastic collision basically is a collision in which the total kinetic energy is conserved. So elastic collision is a collision in which the total kinetic energy is conserved. Now let's take our trolleys again. Okay, we have got this trolley. They are all moving in a straight line, linear momentum. So linear momentum here. But here, take note now, we are talking about kinetic energy. Okay, kinetic energy. So this object here is m1 mass, and it has got a velocity again moving to the right, and this one is m2, and it is what the velocity 2 moving to the left, assuming that they are going to collide. After collision, this is going to move to the right, so m2 will move to the right, okay, and m1 is going to bounce back to the left, so that is v1. So we have got before they collide, and we have after they collide, after collision. So the definition of elastic collision states that when these two objects collide, the total kinetic energy is conserved, meaning that when we calculate their total kinetic energy before they collide, total means we are now going to add the total kinetic energy. So here we are basically going to have, we know that kinetic energy is calculated as EK is equal to half mv squared. It is the energy that an object has due to its motion. So the velocity of the object and the mass of the object, they determine the kinetic energy. So we are now going to take the sum of the kinetic energy here, which is going to be half m1 v1 squared, and this is the initial, okay, plus half m2 v2 initial squared, okay. So this is the total kinetic energy before they collide. According to elastic collision, the collision is described as elastic if this sum is equal to the total kinetic energy after collision, which is half again m1 v1 final squared plus half m2 v2 final squared. So if the total kinetic energy before collision is equal to total kinetic energy after collision, then we describe that collision as elastic collision. In other words, it remains the same. It does not change. But if our values are different, so the total kinetic energy is different from the total kinetic energy after, then we say it is an inelastic collision. So in summary, we describe in form of a formula, we write this as the sum of the EK initial when it is equal to the sum of the kinetic energies final, then the collision is elastic. But when the sum of the kinetic energies EK initial, when it is not equal, when they are not equal, now the value that we get here is different from the value that we get there. When they are not equal, EK final, then the collision is described as inelastic. Now, some of the characteristics that we find in an elastic collision, for example, if you are going to identify an elastic collision, we can also state some differences here in an elastic collision and in elastic collision. Number one, in an elastic collision, you find that there is no deforming of objects. No deforming of objects. Okay, so the objects, they do not break or they don't change the shape. So that is what we also find in elastic collision. But if it is inelastic, okay, there is a deforming of objects. So deforming of objects occurs. Deforming of objects occurs. Okay, so the objects can break or something else change shape. Secondly, under elastic collision, there is no joining of objects. There is no joining of objects. There are certain collisions where the objects will combine and move as a unit. But in elastic collisions, the objects, they do not join. Okay, but in inelastic collisions, the object may join and move further as a unit. So they can stick together and move further as a unit. And then finally, we are saying that kinetic energy is conserved here. That's another difference. That is another difference. So EK is conserved. EK is conserved. So the total kinetic energy is conserved, but here EK is not conserved. So this concept that we have covered here, I've just tried to give a summary of the main concept that we cover in momentum, and please be familiar with them, because these ones will use them when it comes to previous exam questions or even the exams that you are going to get. So one, you must be able to define momentum, and you must also be able to calculate the change in momentum. You must be able to state the Newton's second law in terms of momentum, define momentum, state the principle of conservation of momentum, and also apply it, apply it in questions, and also define elastic and inelastic collisions. So these are key concepts that you must be familiar with. Thank you for watching. Please give your comments below, share the videos, like as well, and don't forget to subscribe.